Hi everyone, my name is Cecilia Lindahl and I'm a researcher at RISE Research Institutes of Sweden. My co-authors are Erik Sindhöj, also at RISE, and Anna Wallenbäck and Lotta Berg at the Swedish University of Agricultural Sciences. Today I will present the results from an experimental study of a novel stunning method of pigs using high expansion foam filled with nitrogen gas. I just want to say something about the other project participants. The project was initiated by Harm Keiserbrink. He's a Dutch entrepreneur and the inventor of the stunning method that we use in the project. Michiel van Miel is working at Anoxia, a Dutch company, and they were responsible for technical development and for design and delivery of the stun equipment. Marianne Gerritsen is an experienced researcher at Wageningen Livestock Research, and he gave expert advice regarding methodology, and he also did a literature study within the project. Rebecca Brattlund Hellgren is a master student at SLU, and she was involved in the practical studies and behavioral studies. So to the background very shortly. Carbon dioxide stunning has been criticized as it is aversive to pigs before they lose consciousness. And nitrogen gas is an inert gas that might be a suitable alternative. Studies on pigs have indicated that pigs show less aversion to nitrogen compared to carbon dioxide. However, there are some technical challenges regarding nitrogen as it has a lower density than air, which means that it's difficult to produce and maintain a stable anoxic atmosphere. So one solution to this could be nitrogen high expansion foam. And the idea of the foam is that it effectively purges the air from a container and leaves a stable controlled atmosphere of nitrogen. The method is allowed for on-farm euthanasia of pigs and poultry in, for example, the Netherlands. And there has been some studies, for example, a previous study showed that it was effective for euthanasia of poultry. But there is a need to evaluate the method scientifically also for pigs. So the aims of the study was to assess the behavioral and physiological responses of pigs to high expansion foam and also to evaluate the stun quality. We also wanted to assess potential aversion to the foam itself by including an air-filled foam treatment. 60 pigs of approximately 9 weeks of age were included in the study. The pigs were divided into 3 treatment groups with 9 males and 11 females per treatment. The pigs were crossbreeds of Yorkshire Dutch Yorkshire Dams and Hampshire Sires. The data collection included video recordings, both from above and underneath the box. Oxygen levels were measured within the box. The pigs wore measuring equipment to measure heart rate, respiratory rate, and activity. And we did a stun quality assessment on the pigs in the nitrogen foam group. Here you see what the test box looked like. The test box had transparent floor and lid so that we could video record from above and underneath the box. The 2 square panels that you see on the wall are the 2 foam generators. The box was also equipped with a gas pulse system so that we could destroy the foam. The open door at the side was where the pig entered the box. The box was connected to 2 50-liter gas bottles and a 3% foam solution. And we had 2 oxygen sensors inside the box to measure the oxygen levels. So to the experimental design, 1 pig at a time was moved from the group pen to a holding pen where we put on the measuring equipment. After 2 minutes, the pig was moved to the test box and it was allowed to acclimatize to the box for 2 minutes before we started the treatment. In the control group, the pigs were allowed to stay in the box for an additional 5 minutes and were then let out, so nothing happened in the box. In the air foam treatment, the foam production started and the box was completely filled up with foam, whereafter the foam was destructed and the pigs were let out after 5 minutes. The same procedure was used in the nitrogen foam treatment, with the difference that the foam was filled with nitrogen, so the pigs were stunned. 5 minutes after the start of the treatment, the pigs were pulled out of the box and we controlled for heartbeats and did a stun quality assessment. Here are some images from the experiments. Upper left, you see the pig in the holding pen wearing the measuring equipment. Below is a pig walking to the test box. In the upper right image, you see a pig inside the box starting to fill up with foam. And the last image is the video view from beneath the box. The behavioral observations was done by one observer watching the videos from both above and underneath the box. The behaviors were continuously registered for a total of 2 minutes, and they were registered in 10-second intervals, so there were 12 intervals in total, and the first 3 were before treatment started. So the foam production, for example, in the foam treatments were in between intervals 3 and 4. For the pigs in the nitrogen foam treatment, the time from start of the foam production until loss of posture was recorded, and there was also a quantitative description of the convulsions. And examples of behaviors were escape attempts, exploring floor or wall or foam, vocalization, lying down, gasping. So to the results. The filling time of the box when it was empty was approximately 40 seconds from start of foam production until the box was completely filled with foam. When there's a pig in the box, the filling time is longer, and that is because when the pig moves, it breaks some of the foam, so it takes a little bit longer. And here you can see that it took longer to fill the box with nitrogen foam compared to air foam. And the reason for that was that some pigs had loss of posture and convulsions before the box was completely filled. And the convulsions very effectively destroy foam. So to ensure that all the air was pushed out of the box, we had to keep on filling the box even after loss of posture and convulsions. So that's the reason for a longer time in the nitrogen foam treatment. The oxygen level in the test box was measured from after foam destruction by the nitrogen gas pulse until termination of the treatment in the nitrogen foam treatment. And the average oxygen level was 0.2% in the nitrogen foam treatment. So now I will show a few figures of the more interesting behaviors that we observed. On the x-axis, you see the different 10-second intervals, and the red arrow indicates where foam production started in the two foam treatments. So intervals 1, 2, 3 were pre-treatment. On the y-axis are the percentage of pigs that showed the behavior at least once during each 10-second interval. So this figure gives a good overview of the nitrogen foam group and the loss of posture. So you can see that loss of posture started during interval 8 and then increased until at interval 11 all nitrogen foam treatment pigs had loss of posture. So this figure shows the behavior exploring of foam. And as you can see, the behavioral responses were similar in the air and nitrogen treatments, with the majority of the pigs exploring the foam shortly after the foam production started. And this indicates that nitrogen gas itself is not perceived as aversive by the pigs, because in that case we would have expected the pigs to avoid the nitrogen foam more. And the similarities here indicate that there is no difference between the air-filled and nitrogen-filled foam. Here you see the behavior escape attempts towards the lid. And also here you can see some similarities between air foam and nitrogen foam. And you can also see here that the escape attempts increase during intervals 8 and 9. And this is when the foam levels in the box are getting quite high. So it's most likely a reaction to when the foam is starting to get over their heads. Here you can see the behavior exploring the lid. And exploring the lid was defined as the pig stretching up towards the lid with its head and snout. And when there was no foam in the box, this was most likely an exploring behavior, but this behavior increased in both foam treatments when foam levels in the box started to become high. And at that stage, it was most likely not an exploring behavior, but rather an avoidance behavior from the foam. So they're trying to keep their heads above the foam. But again, we see similarities between the two treatments, with the difference that the behavior decreases more in the nitrogen foam treatment group during the last 3 intervals, and that's of course because those pigs have lost their posture at that stage. This figure shows the mean heart rate of the pigs in the 3 treatments. And the heart rate is shown as a difference from baseline, and the baseline was measured during the 2 minutes the pigs were in the holding pen before being moved to the test box. So as you can see, the nitrogen foam treatment pigs have a little bit higher heart rate during intervals 6, 7, and 8, and then the heart rate decreases when they start to lose posture. But the standard error bars are overlapping between air foam and nitrogen foam, so it's not a significant difference. time from start of foam production to loss of posture was on average 58 seconds. And this is the time from starting to filling the box, so it's not the exposure time to the gas. Once the pig has its snout under the foam, it goes very fast and it only takes a few seconds for the pig to lose posture. So the time to loss of posture is very much dependent on the foam production capacity. So the faster you can fill up the box with foam, the faster you will have loss of posture. After loss of posture, the pigs had vigorous convulsions for a short period, and then there were more sporadic muscle contractions, like gagging. And the time to the last observed muscle contraction was 131 seconds. 5 minutes after the start of foam production, the pig was pulled out of the box, and none of the pigs showed corneal or pain reflexes. None had any observed movement or signs of breathing. 10 pigs had weak heartbeats, while 9 had no heartbeats at all, and 1 was a bit unsure. So to the conclusions. The nitrogen foam was effective in purging the air from the box and create a stable anoxic atmosphere. The pigs did show some aversive responses when exposed to foam, like escape attempts, and the pigs also seemed to avoid putting their head and snout in the foam when foam levels became high. We didn't see any aversive behaviors that could be related specifically to the nitrogen gas. For example, we observed no gasping. Loss of posture occurred 58 seconds after foam production started, and the time to loss of posture is dependent on foam production capacity. 5 minutes after nitrogen foam production started, the pigs were assessed to be in deep unconsciousness or dead. So based on these results, stunning with nitrogen foam may be a viable alternative to carbon dioxide stunning and offer improved animal welfare. But of course, further studies are needed, for example, to look at the behavior of slaughter weight pigs. So thank you for your attention, and I look forward to answering your questions.